algebra concept today in geometry, just how to simplify radicals and what perfect squares are. So we are going to start with just squaring these numbers and seeing what you get. So to square it, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 5 times 5, 6 times 6, 7 times 7, 8 times 8, 9 times 9 is 81, 10 times 10 is 100. We could go on forever, but we're just going to do up to like 15. Okay, so those are all those numbers squared. The reason they're called a perfect square is because if you took a calculator, like let's say I square root, you hit the second and then this button down here, it says square root. If you square root 225, you get 15. So 225 is considered a perfect square because you can square root that on a calculator and get a whole number. That means it's something times itself. The reason we call this simplifying radicals is because this symbol here is called a radical symbol. Now we're only dealing with square roots, but there's other types of roots. We have cubed roots, fourth roots, fifth roots, but today we're only going to focus on square roots. It says, is it possible to take the square root of negative 25? So we'll try that. Square root of negative 25. Your calculator says domain error. The reason it says that is because this is called an imaginary number. I know we haven't really got to that, but we have the real number system. And if it doesn't fit in that real number system, their calculator isn't going to do it. It's going to tell you that there's an error. So right now, we're just going to say this is no solution. Technically, it's no real solution. And when you get onto Algebra 2, you're going to learn about imaginary numbers. So we're not going to focus on that today. It just means it has an I, like a variable with it when you're doing it. So it's not hard, it's just we're going to focus on what we can't do. So the square root of 49, if you type that in your calculator, square root of 49, you get 7. That means 49 is a perfect square. Technically, if you took 7 times 7, you get 49, but if you also took negative 7 times negative 7, you would get 49. So sometimes you'll see textbooks write this as not only 7, but they might write a plus and a minus sign to show it's positive and negative 7. Now there's a lot of times that we won't necessarily use that in our geometry because we're usually talking about like the length of a side of a triangle. So we only would want the positive one, so that's all I'm going to have you do, but it is possible to take negative 7 times negative 7 and get a positive 49. Okay. Alright, 32. To simplify 32, if you go to your calculator and you type square root of 32, my calculator gives me a big decimal, and we don't want any decimal answers. We want to be able to simplify this. So we're going to look at our list and try 32 divided by 4. 4 is the first number on our list. Since 8 can also be divided by 4, I want to choose a bigger number on the list. So 32 divided by 9, well that doesn't work, that's a decimal. So next one's 16. 32 divided by 16 is 2. So there's no other number on the list that can divide evenly into 2, so my answers are going to be 16 and 2. That's what I'm going to do a little tree diagram for here. The square root of 16 goes on the left, square root of 2 goes on the right. The 16 is the perfect square, so whatever number from this list up here in blue that you write down, that's the number that goes on the left because that's the number you can square root. Okay, so pause the video and try 252. Divide 252 by some of these numbers and see what you get. Which is the biggest one that divides evenly into it? Because 4 goes into it. Let's see if 16 goes into it. It means divides evenly. Okay, 16 didn't work. Think about it. Do you think 25 is going to work? 252 divided by 25? That's probably not going to work because it doesn't end in a 5 or a 0. Let's try the next one. 252 divided by 36. I'm just going along these numbers right here. Well, if you divide 252 divided by 36, you get 7. And 7 can't be divided by any of these blue numbers. So, 36 and 7 are my pair that we're going to break this down to. So, then you square root, this one came from our table, so the square root of 36 is 6. And you bring down the square root of 7. That's it. That's simplifying a radical. Sometimes you might have a number in front of the radical. So let's do 147. Can't be divided by 4. The next one's 9. So 147 divided by 9. That's a decimal. Well, 4 didn't work. 16 is probably not going to work. So let's try 147 divided by 36. No. 147 divided by 49. Yes, that works. So this can be 49 times 3. Square root of 49 is 7. Bring down your square root of 3. What's unique about this one that we didn't have on the last one is the number that's in front of your square root comes down, and you take that number times whatever you get. So 5 times 7, this answer would be 35 square root 3. So let's take 54. 54 divided by 4, that doesn't work, so 54 divided by 9, that's 6. So I'm going to do 9 times 6. That's 54. The perfect square 9, when you square root 9, you get 3. Bring down your square root 6. And if there's a number in front, it comes down and you multiply it. So my answer is negative 24 square root 6. Alright, the next section is on multiplying, which kind of just showed you how to multiply when there's a number in front, but now we're multiplying square root symbols. When you have numbers under a square root symbol, you multiply those. And if your answer can be simplified, you want to break that down. So at the top of our page, 4 goes into 28. 4 is the first number on our blue list there. 4 times 7 is 28. The square root of 4 is 2, and then you bring down the square root of 7. So 2 square root of 7 is our simplified answer. I'm going to leave this one blank because I want you guys to try it, break it down, and then check your answer on the notes that have been completed. See if you got it right. Same thing here, I'm going to do this one, and then I'm going to have you check that one on your notes. So you multiply the numbers in front, then you multiply your square roots together. When you look at your list, 15 cannot be divided by 4, 15 cannot be divided by 9, so this one is simplified. But you may find that when you multiply, that number can simplify, like on the last one we did. So again, I want you to try this one on your own and check with the notes that are put on there. 3 square root of 2 squared is the same as writing 3 square root of 2 times 3 square root of 2, and that is just like the one we just did. The difference is 3 times 3, well that's 9, square root of 2 times square root of 2 is square root of 4. This one couldn't be simplified. This one we can simplify. So you go, okay, well what's the square root of 4? The square root of 4 is 2. And we still have that 9 in front, so you bring it down. 9 times 2 is 18. So, if you have something squared, you just multiply it like we multiplied the last one. This one I'm going to write it out. It's distributing since we have a parentheses. 5 square root of 3 times the square root of 2 plus 5 square root of 3 times 4. We want to see if you can distribute also. This 3 times 2 is 5 square root of 6. The 5 and the 4 are the ones without the square root, so we'll multiply that to give me 20 square root of 3. Since these answers have different square root signs, meaning this is square root of 6 and that's square root of 3, they're not like terms. So like having different variables. If this was x, that's y. If they don't look the same, you can't add those together. Alright, the last thing we're going to talk about is dividing radicals. When you divide a radical, you simplify the answer. The simplified answer cannot have a radical in the denominator. Denominator is the bottom number. Sometimes you can square root the numbers, like 36 and 81. The square root of 36 is 6. The square root of 81 is 9. So sometimes you can individually square root them and then reduce it. That reduces to 2/3. So if you can square root the numbers, square root the numbers. Sometimes we can't. 18 and 200. Those can't be square rooted, but they could be reduced. It looks like 2 probably goes into that. 18 divided by 2 is 9. And 200 divided by 2 is 100. So they might write those with one square root sign, they might write them with individual square root signs, but now these are numbers that we can square root. The square root of 9 is 3, square root of 100 is 10. So I was able to reduce and then square root. The next section is called rationalizing a denominator, because if you do some square rooting or reducing and you end up with a square root on the bottom, we can't leave it there. So rationalizing a denominator is multiplying the top and bottom by that denominator. Because when you multiply by itself, that's like multiplying by a 1 there. So on top, we get 5 square root of 3 over the square root of 9. And when you do this, on top, we still have 5 square root of 3. But on bottom, the square root of 9 is equal to 3. And that is your answer. You can't reduce 5/3. We want to leave it an improper fraction. We don't want to make it a mixed number, so we'll just leave it like that. There are some cases, if this had been like 5 over 15, then we might reduce the 5 and the 15, but 5 over 3 can't reduce. Okay. The next one, rationalize the denominator, because you can't have a radical or a square root in the denominator. We multiply by the denominator. On top you get 10 square root of 2. On bottom we get square root of 4. So on top you have 10 square root of 2. The square root of 4 is 2. So now you're like, okay, well 10 and 2, that can reduce. So if you were going to reduce 10 over 2, 10 divided by 2 gives you 5 square root of 2. You can't ever reduce a number inside a square root sign and something outside a square root sign, like with dividing. Just like here we could reduce, these are both in the square root sign, but here these numbers are both outside square root signs, but you don't like mix and match. This 2 can't go with that 2. So this is the reduced form of 10 over 2 square root of 2. Maybe I should do one quick example of Pythagorean theorem just so everybody's on the same page with Pythagorean theorem. Pythagorean theorem is a squared plus b squared equals c squared. So if we have a triangle, this is the little a, this is the little b, this is the little c. The c is always the hypotenuse. The other sides are called the legs. So it's the leg squared plus the leg squared equals the hypotenuse squared. Just so we're all clear how to set that up. So we'll say we have 4, 9x. So if you want to find this, the 9 is your hypotenuse, or your c. So you're going to do like x squared plus 4 squared equals 9 squared. You'll square them individually. On this one, I would have to subtract the 16 to the other side. And then we would want to square root it. Depending on which worksheet you're working on today, it might have you just say x equals the square root of 65. If the answer choices are given in decimal form, the square root of 65 would equal about 8.06. So it just depends. If it's a simplifying radical one, we'd want to break that down, but no perfect square goes into 65, so that would just be your answer. If your answer choices are in decimals, then you just square root 65 and get a decimal. So just a little review on Pythagorean